Present day everyone, welcome to our session for today. Let's continue our discussion on the implicit differentiation. So this time we will have an application before we solve equation of the tangent line. So we'll do the same here, but this time we'll do the implicit differentiation of our given function. Alright, so the problem is something like this. Determine the equation or equations of the line or lines tangent to the graph of, so this is the given equation, x squared plus y squared equal to 25 at x equal to 3. If you can still remember from your analytic geometry, so x squared plus y squared equal to 25, this equation represents a circle with a radius equal to 5. Okay, because this right side here is r squared, right? This would be r squared, so 5 squared is equal to 25, so radius equal to 5. So we have here the solution. So before I show you the step-by-step solution of this problem, so I'm going to show you first the illustration. Okay, so we have here the illustration. When you draw this equation class, so this gives us a circle like this. So radius equal to 5. So you see here from the origin, the center. So it is 5. So that's the radius. This is also 5. This is the radius. And the line tangent to this circle at this point, I mean at x equal to 3. Alright, so it is the possible tangent line, or it can also be something like this. So it's possible that this is also x equal to 3 here, right? This point here corresponds also to x equal to 3, and it could be that we have this line. Okay, but now to determine which of these two tangent lines, we have to solve for the slope. Okay, slope of the tangent line, so that we can determine where or which of this line exactly is the answer to this particular problem. All right. Okay, so we'll start with the implicit differentiation of this given. So here's our solution. Okay, so from the given, we have differentiating this implicitly. We have 2x, no, first the term. So 2x times dx over dx, which is equal to 1. Then that's for the first term. Then the second term, so we have 2, so power formula, 2 times y times dy over dx. And the right side, derivative of a constant, which is 25, that is equal to 0. So our goal here is to find the slope, right? Find the slope of the tangent line. So this tangent line or this tangent line. Okay, so we need to solve for dy over dx. So dx over dx is equal to 1. Okay, this is equal to 1. Then our equation becomes this will be 2x, then plus 2 times y then multiplied by dy over dx, and this is equal to 0. So our goal now is to first solve for dy over dx. So to solve for dy over dx, so we can, or we will transpose this one to the other side. Okay, and then after that, divide both sides by 2y. Or before we do that, so let's transpose it first. So on the left side we have dy over dx, and on the right side, so we have, so when you transpose positive 2x to the right side, so this becomes minus 2x. Okay, so solving for dy over dx, we have to divide both sides by 2y. So therefore, so we have now dy over dx equal to, we have minus 2x and divided by 2y. So numerator we have 2, denominator we have 2. So this will be, okay, so we have 2 divided by 2, this is equal to 1. Okay, so 1 times x, then this is negative. Okay, this is negative. So therefore our equation becomes dy over dx, dy over dx is equal to, we have minus x over y. Okay, minus x over y. And take note, class, that dy over dx, so this is the first derivative or the derivative of our function, and we know that the derivative of function is just the slope of the tangent line. Okay, so we can call this as mtl, means slope of the tangent line. Okay, so the slope of the tangent line is minus x over y, so we have a negative slope. Okay, negative x over y, so it means that because we need to choose which of this line, this tangent line or this tangent line. But since the slope is negative, okay, so you can still remember from our previous lecture, so when the slope is negative, if the slope is negative, it means that the line or the tangent line is sloping uh, downward to the right. Okay, so sloping downward to the right, this is represented by this line, this tangent line. And this tangent line here is sloping upward to the right, so it means that this is positive. But since the result of our calculation, we have negative x over y, so our slope is negative, slope of the tangent line is negative, so therefore we need to choose uh, this tangent line. Okay, so to solve for the equation, so since we are asked here to determine the equations, okay, so I'll use, okay, so we have here to find how to get this 4, no, the coordinate. We have the x equal to 3, and the corresponding the value of the y is equal to 4. So where did this number is taken from? I will, okay, so I'll just write it here, this part of our slide. Okay, so to solve for y, so we're given the equation here, x squared plus y squared equal to 25. So from here, so we can solve for y, no? So we have y squared equal to, so 25 Then transposing this part here of our given. Okay, transpose this to other side. So this becomes minus x squared. Okay, now solving for y in terms of x. So we take square root on both sides. So when you take square root on both sides, so what will happen, class? Okay, so 2 or 25 minus x squared. Then to solve for y, so we need to take the square root on both sides. So square root on the right side, alright, and then we have square root on the left side. Okay, so index of square root is 2, then you have exponent 2, so this is just like you're just multiplying 1/2 and 2, so that becomes, the power becomes 1. So we have y equal to, and take note that when you take square root on both sides, we have two values, plus and minus. So plus and minus square root of 25 minus x squared. Okay, so at x equal to 3, when x equal to 3, so what will happen? When x equal to 3, so we can now solve for the value of y. So when this x equal to 3, so you have 3 squared, 9. So 25 minus 9 equal to 16, then square root of 16. So therefore our y is equal to, I continue it here, class. So at x equal to 3, so at x equal to 3, substitute this to the equation y, or equation y equal to square root of 25 minus x squared. So at x equal to 3, we have y, sorry, at x equal to 3. So okay, so take this out. So y equal to square root of 25 minus 3 squared. So 3 squared is 9. Alright, so 25 minus 9. So therefore, y is equal to. So don't forget, when you take square root on both sides, you have two values on the right side, plus or minus. So you have here plus and minus. This is plus and minus 4. Because 25 minus 3 squared, which is 9. So 25 minus 9 is 16. Square root of 16 is equal to 4. Okay, so that's why in our illustration class, we have for x equal to 3, no, at this point here, x equal to 3, then our y here is, this is our y equal to 4, right? So that's why we have here y equal to positive 4. And it can also be that if you are referring to this tangent point of tangency and this tangent line, so we are referring to this value, negative 4. Okay, but since our slope is negative, so we choose this line, this tangent line. All right, so we have to choose this line. Okay, this line here, the sloping downward to the right. So what is now the equation of this line? So it means that we have to erase this one, right? So we have to erase this one. We will take this line. So how to find the equation of the line, of this tangent line? So we'll use the point slope form, right? The point slope form. So what was the point slope form, class? The point slope form, we have y minus y1 equal to m. So our m here is the slope of the tangent line, then times x minus x1. Okay, so this is our point slope form given this equation. So what we need here is our y1, and x1 MTL is already solved, which is minus x over y. So when you have x and y values, you can solve for MTL. So what is our MTL here? So our MTL is, so minus our x. So we're referring to this point class. Okay, so the coordinates of this point is x and y. So our x here is equal to 3. Okay, let me change the color. Okay, so our x here is equal to 3. Okay, and then our y is equal to this one here, which is 4. Okay, so substituting, we have x over y, so negative. So this is minus 3/4. Okay, now substituting, so we have y minus y1. So we will use this also our x1 and y1. So y minus y1, so y minus our y1 is this one here, 4, equal to MTL equal to minus 3/4. Then times x minus x1, our x1 is 3. Okay, so manipulating this equation, so let's express our answer in terms of ex. Now we'll express our answer as ex plus by plus c equal to 0. So we'll make our equation of the line in this form. Okay, so multiply both sides by 4. The purpose is so that we can eliminate this fraction here. So when we multiply both sides of this equation by 4, so we have 4 4 times y minus 4, that is for the left side. All right, then on the right side, so we don't have this 4 anymore, this one, because you multiply this side, the right side, by 4. So 4 divided by 4 equal to 1. So what is left is minus 3 times x minus 3. Okay, so distribute and multiply, right? So we have 4y. Okay, so you distribute and multiply. Also this one here, so minus 16 equal to, so this one also distribute and multiply, so that is minus 3x. And this one negative 3 times negative 3. Okay, so negative 3 times negative 3, and this becomes positive 9. Alright, and then so that we can follow this form of our tangent line equation, so we transpose this to the left side. this one, transpose here, and then this one also transpose to the other side. So then write it first. So the negative here, okay, let me this one also. So transpose this to the other side, as well as this one transpose to the other side. So we have, I'll continue it here, class. We have so the 3x becomes, the negative 3x becomes positive, so this becomes positive 3x. Okay, and then write the term with y, so 3x plus y, sorry, 3x plus 4y. Okay, and then we have here minus 16. So minus 16, when you transpose this positive 9 to the other side, so that becomes negative 9. So minus 16 minus 9, so this becomes minus 25. And right side becomes 0 because you transpose everything to the left side, so equal to 0. So this is now the equation of our tangent line. Okay, so I hope it's clear, class. And if you have any question, especially on this part here, this is a little bit confusing, but just remember that you're given at x equal to 3, that is the value of x where the tangent line passes through on a circle. So you solve for y here using the value of x. Substitute in this equation, express y in terms of x, so you get your coordinates, or the coordinates of this point, the point of tangency, which is 3 and 4. 3 for x, 4 for y. Then after that, you use the Points law form. This is the Points law form formula. Okay, so Points law form, and initially we use this as our x and y. When you use the Points law form, you make this as your x1 and y1. So 3 is x1, 4 is y1. Then substitute in this equation. Tangent line MTL, we're able to solve this, that is minus x over y. Then we have x and y here, which is 3 and 4. Substitute it, so you have the the slope of the tangent line. So sorry, this is MTL, slope of the tangent line, MTL, equal to minus 3/4. Okay, then use this in this equation, and then use x1 and y1, and that is for 3 and 4. Okay, then doing these things, manipulating this resulting expression, so we get the equation of the tangent line, that is 3x plus 4y minus 25 equal to 0. Okay, so I hope it's clear, and if you have any question, don't forget to send your message in our group chat, or you may comment on our video below. Alright, so for your practice class, try to solve any one of this problem here. Okay, so for sure there's at least one of this item that will come up during our activity number 2 or assignment number 2, A2, and on our quiz number 3. Alright, so thank you once again. Stay safe and healthy always. God bless. Bye.